have Mr. Foti here, and the question is reaction time a function of age?
I would say the choice I would pick is true. Very confident of choice A. And let me tell you why. Right? The situation that was presented to you was whether or not reaction time will go up or down based on age. How old are you? That kind of thing. Now, when you put it on a graph just like this, you've got your function of age equals reaction time. So based on what you've learned in your math classes, the function of the age, that's your x, so that'd be on your x-axis, and the reaction time would be on your y.
But Mr. Foti, that's not just a math thing, right? Whatever is the f of something, that's always the x value, right?
Right.
I mean, you would do the same thing in physics as well?
Yes, absolutely.
Okay.
Absolutely. Now, what this is saying is as your age goes up, your reaction time is going to go down. That's just a natural thing. As I get older and older, I'm not going to be able to grab something out of the air as quickly. Now, let me put it another way. Your age isn't determined on your reaction time. People say, oh, he's got a reaction time of 3 seconds. That makes him 70, whatever. That's not how it works. You're 70 years old, so you'll have a reaction time of however long it is, 3 seconds, half a second, whatever it happens to be. So I hope that kind of clears it up.
So there you go. So time is in fact on the y-axis.
Yes, time is on the
y-axis. Now
y-axis.
in physics, you often say, oh, a problem has time, therefore it must be on the x-axis, but what's the deal with that? Is that a different kind of time, or?
Well, the time that we're dealing with in physics is absolute time. It's universal time. So I started the stopwatch at this point, and what happened since then happened at a certain time in the universe.
But clearly time here can be on the y-axis,
yes,
and in physics it would be the same thing, right?
Yeah, exact same thing.
Thank you very much.
You're welcome.
All right, Mr. Foti, so you're going to tell us, hi, how you doing?
Hi.
You're going to tell us what the 1/1000th means, what does the slope mean in our reaction time age equation?
All right. Well, here we have a sample reaction time, as I've said before. And we have our slope on our graph. This slope represents, for every 1 year that we age, our reaction time will go up 1/1000th of a second. So, in other words, if we were to go up 1 second in reaction time, we would be 1,000 years older than we had started before. Seems kind of ridiculous since that's way too.
Well, I might live that long. I mean, I eat right and exercise, but a lot of people. Might not make it.
Might not make it to 1,000.
So again, the 1/1000th is 1/1000th of a second per year.
Yeah.
1/1000th of a
words,
second per year. I think I got
put
it.
into a fraction, 0.001 second per year.
So your reaction time is increasing or slowing. You're getting slower by 0.001 seconds per year. Or
right.
if, in other words, if you go, as you said before, up 1 second, I go over 1,000 years, which is kind of silly because you're not really going to be around for 1,000 years probably.
Exactly.
Thank you very much,
Mr.
Mr. Foti. That was fabulous.
You're welcome.
Bang, bang, knock on the door, another big bang.